Here's a great GRE quant question. How many digits are in the number 25 to the power of 6 times 2 to the power of 13 times 7 to the power of 2? So what we get here when we multiply this out is a really big number with a lot of digits, and we want to know how many there are. Well, first order of business, whenever you have a tough exponent problem like this, is to get everything down to primes. What do I mean by that? Well, 25 can be rewritten as 5 to the power of 2, right? It's 5 squared. So I have 5 to the power of 2 to the power of 6 times 2 to the power of 13 times 7 to the power of 2. And if you know your exponent rules, you'll know that when I raise a power to a power, I need to multiply these. So this is 5 to the power of 12 times 2 to the power of 13 times 7 to the power of 2. Okay, we're slightly better off, maybe not a whole lot better off. Here's the trick. Whenever you have a multiplication involving a bunch of 5s and a bunch of 2s, which we have here, what happens when a 5 and a 2 get together? Well, they make a 10, right? Because 5 times 2 is 10. And if I multiply a number by 10, I'm just adding a 0. So what I quickly realize when I'm looking at this multiplication is that this final number, whatever it is just going to have a ton of zeros tacked on to the end of it because I have a bunch of 5s and a bunch of 2s, right? Specifically, how many pairs of 5 and 2 can I make? Well, I have 12 5s and 13 2s. So with that, I can make 12 zeros. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros, right? And I used all my 5s and I used all but one of my 2s. And so now I have 7 squared. That's pretty easy to do. That's just 49. Times this 2 gives me 98. So this number has 12 zeros and then a 9 and then an 8 for a total of 14 digits. For more GRE tips and tricks or to sign up for my live online course, follow the link on my profile.